You have reached the Occasional Podcast, Season 13, Episode 3. The interview subject for today is Peter Ledermann of Soundsmith.
Peter Ledermann of Soundsmith. They sell a lot better than digital turntables.
When I first got introduced to Peter, we talked extensively about what's going on in education to bring more hi-fi designers out into the market. As I'm sure you're aware, if you're listening to this podcast, it's a niche hobby, and there are many paths by which engineers and people interested in the technical side of building amps, DACs, speakers, and sources, they can go. And there's a lot of pretty lucrative options for people. I think this is really a hobby of passions, and you got to really want to do it. But his perspective and insights into education really sparked my interest. I wanted to have him on, but when I got him in the hot seat, I found he knew a lot of stuff about a lot of different subjects, including, is analog better than digital? His perspective, some unique observations on cantilever material, turntable cartridges. Obviously, his company is based around turntable cartridges. And as I listened to the interview, I was kind of left with this thought. First, let it be said that I don't really have a dog in the fight when it comes to analog versus digital. I have both turntables and love them, and I have digital playback and I love it. And we've talked about it a lot on the podcast in a lot of different ways. Now, based around Peter's opinion on analog versus digital sound, his response might seem obvious. A man who produces turntable parts would likely say that he loves the sound of analog. But perhaps, maybe, it's a chicken and the egg type scenario. Is it possible that Peter loves the sound of analog not because he solely produces turntable cartridges, but rather he produces turntable cartridges because he loves the sound of analog? And regardless of what the truth might actually be to you, it does appear that Peter has dedicated a large chunk of his life to educating, learning, and designing analog and hi-fi in general. And we could really use a lot more of that if we want the hobby to survive another 20 years. So I hope you guys enjoy the interview. Peter Ledermann of Soundsmith. Today's episode of the Occasional Podcast is sponsored by Audio Vision San Francisco. Located in the heart of the city by the bay on 1628 California Street, Audio Vision is a brick-and-mortar retail location that has been delivering some of the best sounds in hi-fi to Northern California for over 26 years. Come celebrate with Audio Vision on October 18th and 19th at their huge in-store listening and learning event with 4 full demo rooms with gear from brands like Goldman, YG Acoustics, Nordos, Inuos, REL, and more. The 2-day event is free to attend, and you can find out more details on their store site, www.audiovisionsf.com. Today's episode is brought to you by Pass Labs. For over 3 decades, Pass Labs has delivered unparalleled sound quality. Solid-state amplifiers designed by legendary engineer Nelson Pass and preamplifiers designed by Wayne Colburn come together to bring warmth and transparency to your audio experience. Handcrafted with precision and passion in the U.S., our world-class service department is here to ensure your Pass Labs products bring you joy for years to come. Listen with Pass Labs and discover your music like never before. For more than 25 years, Music Hall has been helping listeners discover and rediscover the magic of vinyl. Their line of turntables is built for every step of the journey, from your very first deck that gets you hooked, all the way to the last turntable you'll ever need. Each model carries the same commitment to musicality, precision, and lasting value. Simple to set up, a joy to use, and engineered to let the music shine. Music Hall turntables make analog playback accessible without ever losing sight of performance. Whether you're just starting your collection or refining a lifelong passion, Music Hall has a turntable designed for you. Find your perfect match at musichalaudio.com. Hey everybody, thank you so much for joining us today. We're here with Peter Ledermann of Soundsmith. How are you doing today, Peter?
I'm doing fairly well for an old guy. How are you doing, Brian?
I'm doing very well for a semi-old guy myself. I wanted to have you on the show because, this season we've been talking a lot about phonograph carts, and Soundsmith is known for some of its phonograph cartridges. And we've had like a really good response from the audience, a little bit educational. We're just kind of digging in and doing a little bit of research on the subject. But you have a very long history with audio. And I was kind of wondering if maybe before we get into the weeds of it all, can you just give us a little bit on your background and how you came to audio and your audio journey?
The journey started very early. When I was literally 3 or 4 years old, I had two favorite things in life. One of them was a 78 wind-up, a portable. Of course, I couldn't move it very far. I was pretty little. And that and a white shepherd were my two favorite objects in life. And often the white shepherd would lie down next to me while I cranked this thing up and listened to 78s. And I was stunned. You know, I loved everything in nature and certainly science, but at a very tender age. And this thing impressed me because obviously no electricity involved. And I stared at it and played it long enough to where I got it. I finally had this intuitive reaction that this was an acoustic fulcrum. It was a teeter-totter. It was transforming a large force over a small area, that is the needle in the groove, matching the impedance or the force of that to a small force over a large area, the output of the megaphone, the air, the impedance of the air. And being a teeter-totter and a fulcrum, I realized it worked both ways. You could yell into the open end of it and make the needle move, and that's how you recorded a record, and you could play it back. So this thing was fascinating to me, and I absolutely fell in love with it. And but I had a germanium crystal radio, and I had, a lot of electronics to play with when I was little. So, but always fascinated with audio and nature and the idea of capturing sound and reproducing it. So it started at a very, very early age. And then, of course, went to junkyards as I got older and picked up everything I could, televisions, radios, and took everything apart and learned how to train the flea circuits of electrons at a very tender age. And, just fascinated by everything in science, everything in nature, and didn't see them as two separate things, saw them as one and the same.
So when you went into education, how did you kind of steer yourself with that passion pushing you from behind? What directions did you choose? What choices did you make that kind of shaped your path?
I understand. I did wound up going to college, but for a very short period of time. I didn't do very well in college. I was not a very good student, although I was a straight A student in high school because I remembered everything that was said in the classroom. And at college, I only made it through 3 semesters, so I never took any engineering courses. So I'm self-taught, and which has pluses and minuses. The pluses, of course, you're not restricted and potentially by what you're taught. You're sort of everything is doable, and then you discover what's not doable and what is. So it allows you to invent things because you don't know what can't be done. The field is wide open to you, and you fail, but that's part of success is failure. So what do they say? Invention is 98% perspiration and 2% determination. So, but yeah, self-taught. I dropped out of college in 1970, I believe, and came home and started a repair shop and repaired stereos. And
Cool.
Eventually met a gentleman named Richard Majestic of CM Laboratories. He was leaving CM as director of engineering and founding RAM Audio in Danbury. Needed a right-hand man. He hired me. I worked there for 3.5 years, helping him develop power amps, preamps. We had a strain gauge phono cartridge system based on the Machusta or Panasonic strain gauge cartridge, as did, by the way, a number of high-end audio companies, Jeff Rowland, John Iverson, a few others, Electro Research. People recognize the beauty of the strain gauge, and Richard was certainly one of them. He was he's still alive, a brilliant engineer. I hope you get to do a podcast with him while he's still on the green side of the turf, he and Renee Yeager, 2 very good friends. Left RAM Audio and went to work for Bozak. I was director of engineering of Bozak, worked a fair amount with Rudy Bozak, the founder, and that was a tremendous experience, designing loudspeaker drivers, loudspeaker systems. I re-engineered their entire electronic manufacturing facility, which had not been in good shape for about 8 or 10 years when I joined the company. I left Bozak after about 3 to 4 years and got a position at IBM Research at the T.J. Watson Research Center, where I worked in the area of surface science for 3.5 years, and then in a division called APTL, Advanced Packaging Technology Laboratories, developing innovative ways of doing chip packaging for ultra-high performance, low-cost, low-weight products. And that was a wonderful experience. I had 3 laboratories and got to do a lot of inventing, took a number of awards, and it was just a dream come true to get in that place, because I'd always wanted to be in a think tank and didn't have the sheepskin to do so. But I proved myself by inventing quite a bit there, because, again, things were wide open to me and I didn't know what couldn't be done. So I thought of things that people with degrees from the best universities in the world didn't think of. Some of them were fairly restrictive in their thinking. It was a good combination to work with people like that, and I had a heck of a good time. Even while I worked there, I kept Soundsmith open as a mentoring business. I'd started Soundsmith in 1970. I recognized there was, back in the 60s when I worked in audio, selling and repairing gear, I recognized a tremendous wave of attrition coming in the audio industry. It was very, very disturbing. I was watching retail stores disappear, and that's where you had a guy in the basement who was whiter than the fallen snow. He'd never seen the light of day or a ray of sunshine. And if you stood out in the snow with your coffee long enough and looked pitiful, he might take you into the basement and teach you something. That's the challenge with audio. There's no degree you can get in it. There's nowhere you can go to learn it. There's no college that will teach it, save for a couple who, maybe the director of the engineering department or the head professor had a penchant for audio and sort of leaned in that direction. I think the University of Georgia had such a gentleman. But short of that, if you want to learn it, you had to learn it from a repair person. You had to join an audio company and work under somebody and that produced equipment. So in the 60s, end of the 60s, I was watching all these things disappear. The Japanese did a wonderful job of making inroads into audio and built some of the world's finest equipment. So American audio companies were disappearing. The retail stores were being replaced by chains and mail order. And I was watching, and there were many other fields. There was medical electronics, avionics, the beginning of software. So a lot of people that might have gone into analog engineering, or used to be called radio and TV, got siphoned off. So there were huge things that caused attrition in the audio industry. And I was watching this and I felt terrible. This was something that I loved. So I decided to start Soundsmith as a mentoring company, and I've taught quite a few people over 50 plus years. And even when I worked at IBM, I kept Soundsmith open, again, at a loss. It didn't make money, but it was my way of giving something back to the audio industry, to create a place where people could come and learn audio engineering if that was something they wanted to do.
Based on your work experience, is there anything that you felt like maybe you did miss out on education-wise, or is it really just a complete waste of money at this point? Because I think that colleges have gotten increasingly expensive. Is it possible, or is it just, in a way, creates an easier path for people through life if they need some structure in order to get to the end goal?
This is a really interesting question, and I have an answer that some people may not appreciate. I think others will. Over the last 30 or 40 years, I've interviewed hundreds and hundreds of students from local colleges who have both 2- and 4-year degrees in electronics. And the experience is nothing short of frightening. Colleges, let me phrase this properly, from a certain point down, it appears to me that colleges are no longer in the business of education. They're in the business of staying in business. They're not teaching in a way that gives people practical skills. Of the 300 or maybe even 400 students that I've interviewed over the last 30 plus years, I have a list of 10 horsey ducky questions in electronics. These are as basic as it gets. And out of the 300 or 400 people I've interviewed, I've probably had 5 or 6 that have gotten through the first 3 questions. The colleges don't teach to prepare you for a job. You study to pass an exam. It's abstract. There's no vessel to hold the knowledge. And this is really frightening. Above a certain threshold, you have colleges that are extremely committed to education and preparing and fitting people for jobs and specific fields. But that also takes a certain kind of person. I'm of a type where I think a lot of people fit into a category where it's difficult for me to learn something unless I have a need to know it. So I'm very fortunate being ignorant. I have a need to know everything. People have asked me, well, how do you teach people electronics when you hire them? And I say I have a very tried and true method. I hand them 60 pounds of lead weight. I walk them over to the deep end of the pool. And when they're not looking, I push them in. And it's remarkable how quickly they learn to swim. I give them difficult things to work on. I don't give them the answers. I let them try and figure it out for themselves. I let them stumble and fall. And I let them do that for quite a while. And then I say, come back to me when you think you know the answer on how to solve this problem. And they come back and they give me an answer. Everything is fine. And then I tell them what I understand the solution is. At that point, the people I've taught have created a vessel. So when the knowledge goes in, it doesn't leak out. It's not like studying for an exam. Now, mind you, in Europe, they teach completely differently. You go to school for 6 months, and they stick you in a damn factory for 6 months where you have to solve problems. And by the time you leave that factory and go back to school, you now have a need to know something. This is how to educate. We don't do it in this country anymore in all fields, pretty much. And you can see how things have suffered as a result. There are CAD designs for mechanical things that fall apart. There are people that don't have a broad depth of engineering skills to know how to do things. It's difficult to get your car serviced. Mm-hmm. This is unfortunate. The mentoring arts are critical. This country was founded on it. In audio, I've watched YouTubes on learning how to service things. They are scary. I'm glad I've done what I've done. What I've done hasn't made a dent in the industry in terms of helping to help it survive, because frankly, in 10 years, all the legacy engineers are going to be gone, and there will be no place pretty much to go and learn it. What the industry needs, and I was trying to get gentlemen who ran big audio companies to agree to this, it never happened, but a school needs to be founded while there's still time. And money needs to be put in so that there are real teachers and they can cull the students that really want to learn something and maybe try and save some of the engineering in this industry. To me, it's a shame because so much has been lost already. So many legacy engineers are gone. So many people who might have wanted to learn had no place to go.
I find that really interesting because part of the reason that I started this podcast was a similar thing. I wanted to capture the personalities, the minds, the thoughts, the perspective into audio from everyone. Like you said, we're on a finite timeline. I wanted to capture this snapshot of what was going on in this certain time because I had the same concern that this will be gone in maybe 10, maybe 15, lucky if we're 20. And I want to capture it for more entertainment, but not so much education purposes. But I do seek to educate more from like a consumer standpoint. I appreciate that idea greatly because I do think that we're going to have some issues here in about 10 to 15 years.
Well, you're already seeing it. If you look at where audio equipment is made, it's made in China by and large, and even expensive gear. And the mindset is different. When I worked at Bozak, we had a gentleman who was a manager of the production area, and he managed the people that serviced things. What used to happen was years ago, you serviced equipment and you got a really, really good feel for failure mechanisms. This is one of the things that I teach when I teach service. That person would eventually migrate up to a position of being a production engineer. Now, follow what happens. You have a design engineer. He designs a circuit. You have somebody who prototypes it out. He builds it. He tests it. You have another guy who lays out a circuit board. Circuit prototype is made. It gets stuffed by someone. And a production engineer who has a background in service looks at the board and says, you know what? You can't do this. You can't do this. You can't do this. You've got a 5-watt resistor next to a polystyrene capacitor. It's going to melt. You've got not enough land area here. The solder joint's going to fatigue and crack due to grain boundary growth and so on. He's going to look at that board and say, you need to change this, 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 and this. And when the board got modified and got produced, that board lasted for a long time. These arts are gone. Now you have people designing stuff that is designed to work for about 2 or 3 years. It comes down production lines where computer parts are made, computer boards are made, which are really only designed to last for a couple of 2, 3 years. I've seen high-end Chinese audio products that are 1 month out of warranty, and you go back to buy parts, and the manufacturer has no parts for them. I come from an era where you went to Pioneer, you went to Sony, and they had parts for 20 and 30-year-old machines in stock. This is gone. And that's kind of a shame, but the art of producing electronics that last, that's gone. And this is one of the reasons, aside from sonic characteristics, why a lot of classic gear is highly valued. You know, we're moving my company right now. I've just moved 300 pieces of classic audio gear that we occasionally sell when people would come into our engineering listening room and they'd want me to put a classic system together for them. Beautiful gear, wonderful sounding gear, and beautifully made, especially once we get all the weak links out of the design because everything fails. But are we building gear like that anymore? By and large, no, because it's a lost art. It's part of the lost art.
In this terms of lost art, what do you think the biggest impact is going to be in the next 10 years of this kind of, you know, replace it in a year culture that's permeating the rest of electronics, as you say? Is it going to directly affect audio in a heavy way, or do you think that audio might rebut it a little bit because we're built in on more a classic architecture of, you know, product development and technologies? We still use tubes, you know, we still adore the record player. Are we going to like be more resilient against this, or, you know, the disposable culture is going to just wreck us in some way?
I think it's an excellent question. I think it's a really very focused and really excellent question you've asked, Brian. I think parts of it will survive and do okay. Without mentioning names, there are tube audio companies that have started, and the people that started them, they may not have a big depth of engineering, but you know, after they fail a little bit, after they build stuff that falls apart prematurely and they learn, their companies are going to start excelling at building stuff that doesn't fail. They're going to relearn the art. Is that going to happen across the board? No, unfortunately not. You know, if you ask somebody who collects or listens to classic gear and compares it to a lot of current, I'll say low or medium cost gear, they'll tell you there's no comparison in sonics. They love the way the classic gear sounded. And there are reasons for that. The circuit designs back then were well thought out. I mean, you could look at a company, we were authorized service for many years for Tandberg, and they had some of the best engineering in the world. You know, and amazing things happen when it's dark 8 months of the year. You know, you look at companies, you look at countries like Iceland or up in Scandinavia. Those guys went to college. I mean, Iceland is like an 80% college graduate rate, but they were dedicated to designing some of the best equipment in the world. Those people, again, are not on the green side of the turf anymore. So much has been lost, and it's really a shame. I understand why it has. Again, a lot of these other fields were very, very critical. Again, medical electronics and avionics and so on. Yes, those fields had great demands for people that knew things and still mentored people when you got your job. But audio was sort of an errant child in a way in the industry. I think to answer your question, parts of it will survive reasonably well. Other parts will not. It is what it is.
So let's keep this in mind and drill down just a quick second. I do not know if this is your field of expertise, but I kind of would just appreciate your opinion. As an example of that, do you think that Class D in an amplifier can be utilized moving forward, or is it something that was just junk? Like, can we resurrect a new technology that's more heat efficient and smaller and make it as good as the old technologies are? Or is that something we just scrap altogether?
I have an opinion about this. You know what opinions are worth. They're worth what you pay for them. To me, Class D, I'm not a big fan of switching amplifiers. I design analog amps and analog power supplies, although I must say I did use a switching supply on one of my MOSFET zero feedback amplifiers, and I was really impressed with the performance. Again, basically because the switching power supply has a very, very low internal impedance, so I was really impressed. Of course, I filtered the bejesus out of it before I fed it to the analog amp, but what it did for the low end was really kind of fascinating. But let's stick with your question about amplifiers. I'm not a fan of switching amplifiers. And a really good parallel to that is the CD. And I have to go, this is a bit of a long answer, I hope you'll forgive me, but let's draw a parallel to the beginning of audio. So it started out with acoustic recordings, the vacuum tube was invented. As soon as the vacuum tube was invented, that allowed a whole array of things, microphones, cutter heads, loudspeakers, amplifiers, preamps, and so on. Early products, they solved some problems. Now you didn't have to put the loudest instrument at the back of the room and the quietest one up near the horn. Now you had microphones. You could do a mix. Did that solve a lot of problems? You bet. Were early devices not that linear? Yes. Did they fix them over time? Absolutely. So by the end of the tube era, you had ribbon microphones. You had really good tube circuitry. You had wonderful, wonderful audio products and recordings. Then the transistor was invented. Didn't sound like tube circuits. They had to really work with it. And there was some early solid state stuff that people like Marantz, Sid Smith and Marantz built, that they did some very clever things in order to get them to sound a lot better, to make them much more linear and lower the distortion. But by and large, it took really a long time for discrete transistor circuitry to be improved. Then the integrated circuit was invented, solved a host of production problems, cost, but early ICs were horrible. Took 30 years to fix them and make audio-grade ICs. Then the CD was invented. Then you had digital. Solved a host of problems, speed variations, the list, signal and noise, the list goes on and on. Did it create its own host of problems? You bet. Audiophiles were aghast at the sound of CDs, and many still are, for a variety of reasons, not just inherently because it's digital, but there are phase errors, there are timing errors, there were a lot of things lost, but a lot of things gained. It's the only field, and some very clever people in audio have pointed out that it's really the only thing that's not been perfected after 30 or 40 years. Why? There's no need to perfect it. Digital does what it does in terms of recording. It solved a host of problems, and it's incredibly convenient, incredibly low cost, and very durable. Is there a need to make it a whole lot better? Well, people have tried, super audio CDs and so on, but there's not a real market to make it better. So this is one of the reasons analog has come back and analog has survived. So let's take that as a parallel back to your question. So switching amplifiers, they solved, like the CD or digital recordings, the Class D amplifier solved a host of problems. A ton of power for very little money. Incredibly efficient, low heat issues. Since they're built on computer lines, even though the circuitry is very complex, again, they solved a host of problems. They brought costs down. You can get incredibly inexpensive 10, 20 watt amplifiers for, $5, $10. This is all wonderful. From a sonic standpoint, I'm not a fan because you have so many components. Do they degrade over time faster than an analog piece? Well, oh, you bet, because they work certain of the components really, really hard. And those components only have a certain lifetime. If they have power on hour lifetime, they have internal heating lifetimes, especially capacitors and small caps. So when you build a switching amplifier, is it going to work 4 or 5 years down the road the same way it did when it came out of the box? It's going to be degrading slowly. Are you going to notice it? Maybe not, till one day when you flip the switch and it doesn't come on. So again, to me, a parallel with digital, it solved a host of problems, created a host of its own.
Do you think that there's anything inherently sacred about the turntable? Do you think part of the love for it is the nostalgia and the tactile experience, or is there some sonic magic harnessed in the technology itself?
Yes, absolutely. There is a visceral fascination with this thing that is basically a micro sculpture that can reproduce sound. I think if Thomas Edison were sat in front of an audiophile system today and he'd listened to what an analog system could do today, he'd be, I think, two reactions. Number one, he'd be stunned that it's still around. And number two, he'd be stunned at the performance. To answer the second part of your question, when I've given a few lectures, I gave one in Germany, in Munich, called Why Analog is Digital and How to Fix It. I referred to a Ortophon engineering article, which I found absolutely fascinating. This Ortophon engineer stated that a medium-grade cartridge and a medium-grade tone arm could detect groove displacement as small as 200 small hydrocarbon molecules. So I said, all right, let me take a high-end cartridge and a good tone arm, and let's say it'll do 50 small hydrocarbon molecules. So I looked up the diameter of a benzene ring. And when I said, all right, if that is the bit displacement or the bit depth that can be detected by a cartridge, how does that compare to 24-bit digital in terms of volume step levels? Turns out it's between 200 and 400 times better resolving. Here was an engineering statement that said this aspect of analog is so much more resolving than even 24-bit digital. Now let's go to the other aspect. Let's go to sampling. Well, you can have, there are some very clever people that I know that have said you really can't do better in principle beyond 96K, maybe double that. There are clock and jitter issues and so on. I'm not going to prove or disprove that. So you can have very high sampling rates. How about analog? That sampling, part of the soapbox I've been on is talking about stylus jitter and how you improve sonics of analog by reducing stylus jitter. What causes jitter? Well, the mass of the cartridge storing energy in the form of inertia. There's a natural resonant frequency in the cartridge. All of that junk is going back down the cantilever into the stylus and telling the stylus, hey, get rid of this energy, move the record. Well, it can't do that. So the only way the stylus can get rid of the energy is to leave the groove wall and bang its way down the groove, basically taking samples. And you might say, wait a minute. If it's only sampling the groove wall, how can it make music? Well, a magnetic cartridge is a velocity generator. As long as it's in motion, like that thing you had on the front wheel of your bike as a kid that made the headlight, light, the faster you went, the brighter it got. As long as it's in motion, it's going to create a waveform. How representative is that waveform of what's really in the groove? Well, that depends on your samples. Depends on your sample rate. If that stylus is banging its way down the groove, taking samples, it's really integrating what it thinks the waveform is. So how do you make that better? You reduce the internal mass, you reduce the amplitude of the resonance, and which is what I do with my cartridge designs, and that reduces the jitter, so you're taking more samples. Does the sample rate vary with analog? Sure. When you have a very complex moment in an analog groove, I promise you the sample rate goes way down because you've got a lot of energy going on. And when you have a more quieter passage, your sample rate goes way the heck up. So it's a variable, but the bottom line is when you consider all things together, when you hear a really good analog recording with a really good cartridge, almost every audiophile that's in the analog will tell you that no digital recording comes close. And I can tell you I have two Neumann lathes. I have a charity project called Direct Grace Records. We cut direct to disc mainly, and the records go to rescue children around the world in slave labor. An experience that is unlike anything else is cutting a lacquer, what's called a dub, a 12-inch lacquer, on the lathe as a test cut, taking that dub over to my turntable and playing it with a strain gauge cartridge and listening to it and just being stunned that you can get that kind of resolution, that kind of signal to noise, that kind of quality out of this mechanical system. It never ceases to amaze. It's like a bumblebee that shouldn't be able to fly. It's a hummingbird flying thousands of miles. They're monarch butterflies that congregate in one small area. These are all, to me, miraculous things and not dissimilar. So analog, yes, part of it's visceral, and you have to treat it like a fine wine. You have to decant it and pour it slowly, let it breathe. Or you can have digital, just have a shot of whiskey, There is a visceral component to it and a care component to it, but there's something so remarkable when it's done right. When it is, it's just, it's overwhelmingly beautiful.
This episode of the Occasional Podcast is brought to you by AudioQuest. All AudioQuest products, from the company's most modest parts to its most ambitious works of art, are thoughtfully designed to deliver outstanding performance and exceptional value, regardless of price. No matter how little or how much you invest, AudioQuest is made for you. Explore AudioQuest's award-winning cables, power products, and accessories at audioquest.com. Tired of audio reviews that sound like they were written by robots? Us too. For the last 15 years, Part-Time Audiophile has been an open revolt against boring. And this year, we're doubling down. We have a brand new look and a brand new name, but the same old attitude. Find us at pt.audio for all your turntable throwdowns and amplifier face-offs. Great sound meets good times at pt.audio. Today's episode is sponsored by Shit Audio. Shit Audio designs and builds audio components in Texas. Their wide line of amps, DACs, and audio accessories fit any budget, starting at $49. For a full rundown of all their products, visit shit.com. That's SCHIIT.com. Can you give me just a little more technicality on the sample rate of analog? Because to my understanding, the sample rate in digital is the more times it's sampled over time. If analog is just recording like a needle onto a record or a lathe onto a record, how would there be any sample rate at all? And because this has come up before that someone has said on this podcast, there isn't really a sample rate for analog. It's just running consistently. You mentioned sample rate there. Is that not true?
That's not true because here's a good example. Why would you cut a half-speed master instead of cutting at normal speed? That's something I would ask that person who made that statement. When you cut, and I've cut half-speed masters, okay? When you cut at half speed, you have 4 times the energy into the cutting head to get that stylus to displace where it needs to be. It's much more linear. Now, that's not jitter per se, but it's much more linear. The real jitter comes with playback because now you have a stylus, a cantilever, and some sort of mass inside the cartridge system, which you have to schlep around at up to 20,000 times per second in different directions. At one moment, you're telling it to go this way. The next moment, you're telling it to go the opposite way. That stored energy in the form of inertia will not allow the stylus to stay in intimate contact with the groove wall. The physics of it say no, no, no. Plus you have a natural resonant frequency. It's like a bell. Everything is a natural resonant frequency. Your cat, your dog, your car, your spouse. So here you have a sprung mass. It has its natural resonant frequency. It's actually a spectrum of frequencies and of different amplitudes. And that all marches back down the cantilever and gets into the stylus, and the stylus has to get rid of that energy, and I've described how it tries to do that. So yes, there is stylus jitter. That's the soapbox I've been on. My thing is build cartridges with far, far lower internal moving mass to reduce the jitter, because that reduces groove noise. What? Groove noise? How could it reduce groove noise? I'll explain that. And it also improves the quality of playback because you're getting basically more samples, less jitter, much more linear reproduction. Why does it reduce groove noise? Well, because that jitter produces a spectrum of frequencies. Let's say most moving coil cartridges have a natural resonance between 30 and 50 kilohertz. You say, oh, wait a minute, that's above human hearing. That shouldn't be a problem. Well, it is. If you take a 30 and a 40 kilohertz resonance and have them together, you get what's called sum and difference products. You get a 70 kilohertz resonance, plus you get a 10 kilohertz. Well, that's well in the spectrum. So these resonances cause the stylus to jitter and create signals in the upper part of the audio band that sound like groove noise. We get, and I realize this is somewhat immodest, but we get a lot of emails from customers saying, hey, I just got a Soundsmith cartridge. What the hell happened to the groove noise? They don't understand why it's so much quieter, and I explain it to them.
In terms of hearing things outside the audible spectrum, we always talk about this 20 to 20 thing. In the last podcast, I just spoke about it too. Several people have come on the show and said that it does, in fact, impact the things we can hear in the audible range. From your experience, the things you've done, is there an impact? And if so, what has that impact been?
I should probably answer that by saying, what? Could you repeat that? I couldn't hear you. Sorry, Brian, it's a bad joke. So I don't have a fixed opinion about that from a personal experience standpoint. From a theoretical standpoint, could information above 20K interact with stuff below 20K? Again, sum and difference products to affect the audible presentation? Potentially, yes. Have I experienced it or done a lot of research in that area? No, I haven't. But I wouldn't say absolutely no, that's ridiculous. I know there are tweeters out there that go out to 100K, and in years past, people bought them and they went, oh my word. Now, whether that was the wallet thinning effect, when you thin your wallet and you sit down on your wallet, it puts less pressure on a particular cranial nerve on the back end of you, and you can hear a lot better. I don't know if you're familiar with this acoustic phenomenon, but and when you buy something expensive, you can trick yourself into saying, oh my God, it's so much better. I would, in my 50 years plus, people have asked me about, well, gee, I have one of this cartridge, and maybe it's one of mine, and they go, gee, I'd like to get this higher-end Soundsmith cartridge. What am I going to experience? And I've told them it's part of my audio faith tradition to never, ever, ever tell anyone what they're going to hear. I have no way of knowing. I can tell you technically why it's different. I can tell you technically why it theoretically should be superior. But are you going to hear a difference? No, I have no way of knowing that. I've met people that hear a lot better than I do, and it's always impressive. A good thing, because it puts me in my place. I had an interesting experience I'll share with you if we have a moment. When I worked at Bozak, I designed a loudspeaker, and I was tweaking the crossover. And by the end of the day, it sounded pretty good. And when I came in the next morning, I listened to it, it was horrible. And I said, all right, let me go back to the original crossover design. It sounded okay. And every hour I went back in the listening room and I was tweaking the crossover, and end of the day, it sounded okay. I came back in the next day, listened to it, it was terrible. And this repeated itself for 3 or 4 days. And then I went and looked at my lab book, and I looked at the changes I was making to the crossover hour to hour. And wouldn't you know, I was making pretty much the same changes hour to hour. And I was young. I was in my 20s. And I went, good Lord, what an incredible lesson for me. My hearing is changing hour to hour based on blood pressure, stress, blood sugar, you name it. And since that period of my life, I do not trust my hearing, especially on one hearing. If I design something, I listen to it, I go back in the next day, I listen to it over several weeks or more. I bring other people in, I say, what do you think? What do you hear? And so on. And I tend to keep my opinions about things pretty loose because I don't trust that my hearing is objective. It's not. I got proven to that at a very early age, and it changes hour to hour. Maybe I'm somewhat unique and my hearing is worse than others or more changeable than others. I don't know that answer. But I know the experience was a really important lesson for me to distrust an immediate fixed opinion about how something sounds.
Do you find yourself leaning into more like the measurements and the graphs to help fill that gap? Or where do you stand on your reliance on measurements with that in mind?
Sure. The interesting thing about audio measurements is that they're not going to tell you, by and large, how something sounds. They're really not. We get a lot of compliments on my little speakers, my Monarchs and Dragonflies, and they're based on an experience I had at Bozak, which was an engineering accident. I discovered a method of measuring loudspeakers that was quite accidental, and it was incredibly revealing. And I went and showed the graphs and paperwork to Rudy Bozak, and he looked at it and he said, how the hell did you do this? And I said, well, Rudy, it was an accident. And I explained what happened and how I did it. And he said, what happens when you change the crossover? Does it affect these readings? I said, Rudy, if you look at the crossover cross-eyed, it changes the readings. And he said, and do these equivocate to the listening experience? And I said, in a ridiculously exacting way. And he said, nobody's ever done this before, to my knowledge. He said, you need to write a paper to AES about this. And I said, Rudy, I'm here 14 hours a day, and I'm not sure I could even do it properly. Would you write it with me? And he said, yes, but we never did. I used that technique and that discovery to design loudspeakers, including the monarchs and butterflies, and we get and dragonflies, and we get a lot of compliments. It shows on those speakers. People are stunned at the performance of these stand mount speakers, and it's based on that accidental experience I had at Bozak. But by and large, readings are not going to tell you how an amplifier sounds, how a loudspeaker sounds. They're just not. And what is going to affect, let's talk about a loudspeaker, because they're remarkable things that should not work as well as they often do, or sometimes do, I should say. I designed a loudspeaker at Bozak once, and I asked Rudy to come and listen to it, and he politely listened for 30 seconds. And he got up, put on his little felt cap, and he went to leave the sounder without saying a word, and then he turned and he looked at me and he said, you know, when you're designing an electromagnetic transducer, he said, there are 10 things you'd like to do. You're only going to get to do 3 of them. You'd better pick the right things. And he turned on his heel and he walked out. And I sat there for a while and I thought, well, did he just diss me or did he just lay a lifetime of wisdom on me? And it took me a moment or two. I'm a little slow on the uptake sometimes. It took me a moment or two to realize he had just laid a lifetime of wisdom on me. You have to pick, when you're designing anything in electronics, loud, a transducer especially, but even electronics, even circuitry, you have to determine what are the most important 3 or 4 things you must do really well. Put those at the top of the list and do those to the best of your ability. Everything else you tweak. If you do that and you're good at it, the things you have designed and built will stand on their own. But when you put them together as a whole chain, as I've had the good fortune to be able to do, from cartridge all the way through electronics to loudspeakers, then a magic happens. Then the whole is greater than the sum of the parts. And I have to say, and this is incredibly immodest, so please forgive me for this, I've been in a lot of shows and gone into a lot of sound rooms. And if it doesn't sound good out in the hall, I don't go into that room. Some rooms just don't sound good, and the equipment can be incredibly expensive. It's not a question of money. It's a question of insight, intuition, and engineering on the part of the engineer. And there are some unbelievably wonderful pieces of audio art that have been brought to fore over the last 60, 70, 80 years even. And again, based on the intuition and understanding of the engineer. Can you measure that? Not really. Not really. Could you do a chemical analysis maybe of a bottle of wine to determine how it's going to taste? Maybe not. Could you, nobody's figured out how to build a Stradivarius. You know, it's the Young's modulus, it's the grain, it's the varnish, it's the mechanical impedance of the sounding board to the air. It's lost art. So intuition is really important in engineering, and measurements don't reveal intuition and cleverness. So I hope that answers your question.
You mentioned focusing in on 3 key aspects that you find most important when engineering. How do those 3 most important things vary from product category to product category? You've had, obviously, as you said, you worked on different products. How is the top 3 requirements different from a turntable than it is from a speaker, than it is from an amplifier?
Sure. So let's talk about a tone arm. Like a very dear friend who's one of the most brilliant people in audio, and you should be doing a podcast with him. His name is Frank Schroeder. He's very famous.
Does he have a cat?
Frank, he does have a cat. I think he's got several cats. And by the way, he's the one who called me years ago and said, and very diplomatic, Frank is an incredible human being. He said, Peter, what's on your research list for cantilever materials? And because he had a thought, but he didn't want to pollute my thinking, which is, that's Frank. It's brilliant.
Yeah.
And I got down to the 3rd thing, and I said cactus spine, and he said, stop. He said, where are you with this project? I said, well, like 120 some odd other inventions that I've worked on or wanted to do. It's on the list. It's part of, he said, moves this up to the front burner. And I said, why? And he said, because I've just put some cactus spines in the mail to you. And when they came, And I looked at them under a microscope and dissected them. I could not believe what I'd seen, and built a cartridge and did a test. Now, I'm going to fly against what I just mentioned. I did a pulse test on it, and the pulse test was ridiculous. And I realized this was God's gift to analog. It solved so many problems with cantilever design. And again, nobody had done anything with cantilevers for the last, 40, 50, 60 years. There are a lot of things in audio like that. It's one of the things I love about the field, because it's such a small industry and often by, small companies. And if you're a small audio engineer, a limited number of people, you invent something and you get it to work and you're thrilled. And one part of you goes, keep tweaking it. And the other part goes, look at the pile of bills on your desk and the employees you have to be responsible for, and bring the damn thing to market. So there are a lot of things in audio that have not been perfected or resolved. And that's my joy, because if I think about them, I may think of something not just for marketing. I may think of something that's a breakthrough, that's a real gift to the audio industry, or to analog especially. And that's what the cactus spine is in my Hyperion cartridge. It solved a host of problems. What things are important, they vary. In phono cartridges, it's the moving mass in part. In tone arms, when you look at Schroeder's arm, it's the material and the mechanical impedance mismatches in the tone arm. It's the bearing design. It's what happens to the energy. Just like a cantilever, what happens to the energy goes up the cantilever into the moving mass. What happens to the energy in a tone arm? It has to go up and get resolved, not reflect back down. So loudspeaker, ton of things that are important. Transient response, phase response, the list goes on and on. The human ear lives in the time domain, not so much the amplitude domain. So we're very sensitive to things that have time shifts. This is how we learn to hunt. Even if a sound arrives louder in one ear, if it arrives in this ear before this one, your brain still tells you it's coming from over in that direction. We were hunters. We're not as good as animals in terms of hearing, but we're pretty good. So we live in the time domains. When you listen to music, when there's a time shift, it's a problem. This is why some mono recordings, even some early ones, are really wonderful, because there are no timing errors. It's a single microphone. I had an employee who was a mono bigot. And one day we build mono cartridges. We can turn all of our magnetic cartridges into dual coil monos, true monos. And I built one for a customer, and I brought him in and I put a record on, and playing him this mono recording with one of our mono cartridges. I said, what do you think? He goes, God, that recording is incredible. I said, it really is. I said, you're listening to mono. And he was stunned. He thought I shot his dog. Timing is important. We live in the time domain. It's important to get that right with a lot of products. Power amplifiers, preamplifiers. I build solid state ones that are ultra low distortion, because I have to hear everything that's going on. Tubes, they generate harmonics, even order harmonics. They're very musical and warm and wonderful. I'm not saying anything against them. It can solve a lot of problems in the system in terms of smoothing things out. It's like a beauty queen. She looks really good at about 15, 20 feet. You don't get any closer, you're going to notice some imperfections. So tubes can do that. They can warm things up. But I have to listen to solid state gear that I've designed that is ultra low distortion, because I don't want to add anything. I don't want to mask anything. Other than that, measurements, design criteria, I'm directed towards designing things that are as revealing as possible, as accurate as possible, and I use my intuition as best as possible to put the most important things up at the top of the needs chain.
I love any conversation when we talk about audio that brings up our hunter-gatherer scenario. When we talk about psychoacoustics and acoustic designs goes back to this idea, and I love it. It's a recurring theme that people bring up when they're really big into thinking about how we've developed over time, how we really hear now, and why we hear the way we hear in regards to survival. I mean, that's how a lot of things change. How do we do things based on our survival and how it's going to help us survive longer and this kind of thing. So I appreciate it greatly when anybody brings it up, because it doesn't get brought up enough, I think, because this is a very interesting topic when it comes in terms of like how we manage height. Like, how do we know something's above us if it's coming down? How do we manage location?
Right. Now, this is a really interesting subject. By the way, in terms of listening to things, people talk about break-in periods for various gear. They tend to leave out the psychoacoustics. And those of us who've been married understand you can get used to almost anything. Sorry about that, Brian. And if you spend enough money on something, after a few hours or days, it's going to sound a lot better. That's certainly part of it. There's a psychoacoustic effect. Is there a break-in period for certain, electromechanical pieces? Sure, I'm not going to deny that. Electronics, I'm not going to deny that either. A cable, I'm not going to talk about that. But the bottom line is we can get used to almost anything and we get comfortable with things, but it does take a while. We tend to love a stereo system once we tweaked it and bought the right stuff. And then there are other people that are never satisfied, which is wonderful as well. They're always looking for something better. But the bottom line is you're right. We are sensitive and we're discriminatory, but we can get used to things and get comfortable with things. And that's a good thing because a lot of life is can be pretty uncomfortable. So it's a good thing that we can buffer a lot of it, not just a musical sense or a hi-fi sense, but in our lives in general.
We were talking about the different areas for growth in hi-fi, and I was wondering if you thought or how you think in terms of the turntable and how long it's stuck around and it's had time to be refined. It has plenty of components to be refined. Digital shorted some of that out, and we talked about digital and how it's being refined still. Do you think that there's, like, between the turntable, digital players, amps, and speakers, any of those categories are more flushed out than others in terms of their technical prowess? Or some, and then the inverse of that is, which category or which product do you think still has the most potential for growth in terms of hi-fi, getting more, squeezing more out of it? Or are some fully squeezed?
You have to look at the most difficult things to design and manufacture in audio, and those are going to be transducers. So you're talking about cartridges, microphones, loudspeakers. Everything is a compromise, absolute compromise. From the standpoint of cartridges, moving mass is the enemy. It's why I focus on building cartridges that are unique from the rest of the industry. They have 5 to 8 or 9 times lower moving mass than moving coil. To me, that's a plus. The strain gauge cartridge, no moving mass at the end of the cantilever. None. It's a nearly perfectly terminated cantilever. No reflections. It's one of the reasons the strain gauge will play a lacquer hundreds of times without damaging it, where no magnetic cartridge will do that. So transducers, very difficult. Loudspeakers, so many different technologies for loudspeakers. I have very fixed ideas about loudspeakers. Microphones, obviously, there have been some incredible microphones designed over the last century. Some wonderful ribbon microphones and obviously condenser mics and so on. But they're all different. They each have a signature. To me, are some of the most difficult things to design in audio. Are people going to have breakthroughs? I hope so. Back to the beginning of the conversation, a lot of the legacy intuitive engineers are going to be gone. They're not going to be around long. And they haven't been replaced. So I don't know who's going to fill that void. As much as I love audio, and especially analog, it's obviously a concern.
Is there anything that's been perfected in audio, in your opinion?
I don't know that I have an answer for that. I really don't know. There are certain amplifiers that I've tried to base some of my designs on that I really love. They seem to do everything right. And I think that's why when people have heard my system, and I've had customers come and listen and say, wow, your tube amplifiers are just, God, I love the sound. And I say, well, those aren't tube amps. Those are solid state. And many of them are stunned. They say, well, I can't listen to a solid state amp. I said, believe me, I get it. A lot of them don't sound very good. I said, well, good Lord, these things, they're invisible. I said, I know. So there are some things that have approached being really, really good. Transducers, I have some ideas for designing loudspeakers. I don't, new ones. I don't know if I'm going to live long enough to do it. Getting kind of on, and I don't know that I have the backing to do it from an investor. There are a lot of things I'd like to do. I'm sitting on over 120 inventions. I won't get to even do a fraction of them. It's hard for an individual investor, and a lot of the funds I've used for this company, I've used for training and teaching people and for my charity projects, and I'm not bemoaning that. there's not time to do everything or resource to do everything. I don't think I can point at any one thing and say that that's perfect.
So when you look back on all of the things that you have created or done or had a hand in, is there any one particular piece that you're most proud of? Or did you have a couple of things that you were like, this is such an incredible thing, but it didn't really take off in terms of sales as much as the other ones?
In terms of audio or what I did at IBM, you want to keep it?
I'll open it up to whatever you want, honestly.
I consider it divine intervention that I wound up at IBM without a degree and got to work with really brilliant people in a think tank. The Watson Research Center was a dream come true for me. And the beautiful thing was, again, I didn't know what I couldn't do. So I did a lot of inventing there and won some awards. And I had some breakthroughs and some breakthrough ideas. And I look back at those and I'm just incredibly grateful that the powers that be forced open the doors and threw my butt in there. It actually started by a baby robin falling out of a tree and my taking care of it, a little hairless baby robin. You never know what the chain of events are going to result in. In terms of audio, probably the strain gauge phono cartridge. It's ridiculous. It's so revealing that if you have a really good piece of vinyl and you play it with that strain gauge, there's nothing that comes close. And I was so glad to resurrect it. It was invented by Sal Wynn, a Cambridge-trained physicist who bought a strain gauge factory in Puerto Rico back in the 60s. And being an audiophile, realized he could build a strain gauge cartridge, which he did, and Wynn Labs was born. You know, that cartridge had a rough time because only a handful of people listened to it, really were able to hear it and fall in love with it. Everybody else just wrinkled up their noses, and for good reason. It was so different. And again, as we talked earlier in the conversation, you can get used to almost anything. We don't have acoustic memory in the way people think about it, but we do know how something kind of sounded and what we're used to. So when you hear something radically different, even if it's better, you have a good chance of saying, I don't like that. But the strain gauge has grown into a lot more acceptance only because other cartridges in the field have been improved over the last 30 or 40 years. And so the disparity between a strain gauge and a magnetic cartridge, I won't say it's disappeared, by and large, because it has not, but the gap has shrunk. So I think that's a product that I was able to re-engineer, get some of the original bugs out of it, because there were a few, and produce a very, very high performance, what people call a world-class cartridge, with user replaceable styli, really unique. So I'm very proud of that. So I think that stands out.
What advice would you give to someone today? Seeing you just talked about your transition to IBM and how impactful that was on your life. Can you explain in like simple terms to someone who's looking at a job that may not have a degree, but even if they do have a degree, how did you find your way into that position? Because there's a lot of talk about soft skills. What skill or what technique did you employ in order to make that big step in your life?
So I'm going to tell you an advice I gave to somebody who worked for me years ago. When the company broke up and he left the company, he said, well, what should I do? Because he'd shifted from the field of English into audio and engineering. I said, go find a mentor. Go find a small audio company. Go work for that guy. You're going to bust your butt. You're going to work a lot of hours. You're going to be thrown in the deep end of the pool. You're going to be asked to solve problems you're not going to know how to solve. And after 3 or 4 or 5 years, if the company grows, hopefully you'll be compensated for it and you'll get a much higher position with the company and much more responsibility. If it doesn't, look elsewhere. Take those skills you've learned and move elsewhere. One of the young men that I trained many years ago, I met him when he was 18 and he wanted to learn. And he worked for me a number of years. And then he said, I need to get a different job. I said, that's fine. Go with it. Let me know what I can do to help. And he came back after his interview, and I said, how'd it go? He said, well, the guy put a schematic in front of me, and he said, does this mean anything to you? And he said, yeah, here's the power supply, here's the regulated circuitry, here's the preamplifier, and here's this. And he pointed out all the sections, here's the protection circuitry, and he said, the guy looked at me, he said, how the hell did you learn how to do that? And he said, well, I worked for somebody that taught me electronics, taught me how to service equipment. I can't tell you how valuable that is, learning those skills. I have taught people audio engineering, and they've gone off into other fields, but what they've learned of electronics and engineering Some have stayed in audio. Jeff Joseph of Joseph Audio was one of my students. His mother used to joke, other mothers were bringing their kids for piano lessons. My mom used to drop me off at Peter's basement. People have used practical skills to get into other fields. One young man I taught, he called me a few years later. He said, Peter, I'm down here in Virginia. I'm with a company that does environmental controls and engineering. It's my second day on the job. I don't know what the hell I'm doing. And I said, his name was John. I said, John, I've never had a job where I knew what I was doing. You will learn. Take everything I taught you, take everything you have learned. They're not going to expect you to know everything on the first day, but keep your ear to the ground. Study. Go home. Look up stuff. Come in the next day. Be more educated. I taught this guy for 3 months. Nothing, just on weekends. And he came in one day, there was a tuner, and I had a problem. And I said, well, John, we have to figure out. He said, oh, well, it's probably the front end local oscillator because we've got IF noise and he went on. I said, John, where the hell did you learn to do that? Oh, well, I went to the library and I did some reading after you showed me the problems with the tuner last weekend. I said, John, that's very impressive. So you have to be willing to be willing, and you have to find someone to mentor under. You have to find someone who will take you under their wing, and you're going to have to pay your dues. Those skills will be invaluable. You will be valuable. And that's my strongest advice for anyone who wants to learn in any field. Go pay your dues. The job's going to be rough. Smile. Do everything you're asked to do and 100% more. Make yourself valuable. Make yourself useful. Use the time, which is short. Our lives are short. Use it wisely.
Peter, thank you so much for your time today. I appreciate it and all your insights. It's been a joy. The Occasional Podcast is a production of the Part-Time Audiophile Network, which includes parttimeaudiophile.com, The Occasional Magazine, the PTA newsletter, and audiohead.com. You can stay in touch with us on Twitter, Facebook, Instagram, and YouTube. The Occasional Podcast is produced and hosted by Brian Hunter, executive produced by Scott Hall at PTA Productions. The Occasional Podcast and its original associated music is monitored, mixed, and mastered on the Focal Trio 6 BE studio monitors. AI songs produced by Udio.com. If you haven't already, please subscribe to The Occasional Podcast on iTunes, Google, Spotify, or wherever your favorite podcasts are downloaded.